Live started.
Yes, sir.
So, for the first test, the questions were much simpler this time. So, you have done some certain mistakes, so I'll just go through the question paper. Preliminary means we'll discuss tomorrow, prelims today we are discussing. And in mains, basically, all of you have made a common mistake, especially in question number 2. So, question number 2 talks about the fault and how fault is shaping up what? How fault is shaping up the Earth's surface and causing earthquake. So this was the question. That what is fault and how fault is shaping up what? Shaping up the Earth's surface and earthquake. What you all have done is you have written types of fault over here. So all of you have written more about types of fault. As we discussed, what is the key word in the question? Keyword is how fault is shaping up the Earth's surface. So fault is causing what? Block mountain to form. Fault is causing what? Rift valleys to form. So you have to explain more about these terms, that how the fault is shaping up the Earth's surface, rather than explaining more about types of fault. So that's where you have gone wrong. All of you have gone wrong in question second. Question 1, more or less okay. Everyone have written with certain more fine tuning is required. So we'll discuss what are the content that you have to add in question number 1 and question number 2 tomorrow. For now, we'll just take up the prelims part today. So the first question says, which of the following explains the Big Bang theory? So answer will be what? B. Sudden singularity concept. We discussed in Big Bang theory what is happening. Singularity concept is there. So because of singularity, explosion is happening. So sudden explosion of singularity best explains the Big Bang theory. Question 2, what is considered as the main evidence supporting the Big Bang theory? So it is cosmic microwave background. Yes, it is a cosmic microwave background. So we discuss either redshift or cosmic microwave background. Those are the evidences. Or the inner core of Earth is composed of iron and nickel. Yes. Okay. So this is Third, again answer will be B. Fourth, the discontinuity between crust and mantle is known as Moho discontinuity. So the fourth and again answer will be what? Fourth again answer will be B. The fifth is which layer is responsible for Earth's magnetic field? Outer core. It should be outer core. So we discussed outer core is in which state? Liquid state. And because Earth is rotating, this liquid inside Earth is moving, which is leading to generation of what? Generation of magnetic field. So answer here will be fifth B1. Sixth, which of the following is example of igneous rock? So answer will be again B. Granite is what? Example of igneous rock. Marble is an example of metamorphic rock. So limestone is converted into marble. Marble is an example of metamorphic rock. Slate again is an example of, remember, clay shale is converting into slate. So slate is again an example of metamorphic rock. Sandstone is an example of sedimentary rocks. So only example that is okay, there is a granite, which is an example of igneous rocks. Which of the following rocks is formed from the sedimentation? So as we discussed, sedimentation, rocks formed due to sedimentation is which type of rock? Sedimentary rocks. Rocks formed due to sedimentation is what? Sedimentary rocks. We know that sedimentary rocks, sediments are brought by the rivers, sediments are brought by winds and etc. These sediments get deposited and forms okay what? Form sedimentary rocks. So if question says which of the following rocks is formed by sedimentation, you have to look for which rocks is sedimentary rock. So here basalt is which type of rock? Basalt is which type of rock? Igneous rocks. So basalt we have discussed which type of rock it is there. It is igneous rock, so it is not a genesis. Genesis is which type of rock? Metamorphic. We discussed granite is converted into what? Genesis. So genesis is metamorphic rock. Schist again is a metamorphic rock. Which is the sedimentary rock over here? Limestone is a sedimentary rock. So that you have to keep in mind. 7th will be the answer. Next, 8th, the process of rock cycle involves only igneous and metamorphic rock, transformation among all three types of rock, only sedimentary rocks, and formation of new elements. So here rock cycle involves what? All. Okay, so we discuss igneous rocks is converted into what? Sedimentary. Sedimentary is converted into metamorphic. Then sedimentary and metamorphic can cause what? Melting and again forms what? Igneous rock. So this cycle involves transition amongst all three types of rocks. So answer 8th again will be B. 9th, diastrophism is related to
B.
so movement and deformation of Earth's crust. Diastrophism. Remember we discussed two types. Endogenic forces can be categorized into diastrophism or slow forces, or catastrophism or sudden forces. So diastrophism means movement and deformation of Earth's crust. So that is going to be 9th answer will be B. 10th, exogenic forces are responsible for volcanism, folding of crust, weathering and erosion, earthquake. So again exogenic means what? Endogenic and exogenic. Exogenic means above the surface of Earth. So what is happening above the surface of Earth? Weathering and erosion. Volcanism, folding, earthquake, these are part of endogenic. These are part of endogenic. Folding generally occurs due to compressional forces. So we discussed two types of forces. Faulting occurs due to what?
Tension.
Tensional forces. Folding occurs due to the compressional forces. So 11th C will be the answer. Anticline and syncline are associated with folding. Again, anticline and syncline is associated with folding. Next, rift valley are formed due to, so just now we discussed what is the reason for rift valley formation? Faulting. So we discussed faulting is leading to block mountain formation. The part that goes down called as what? Called as a rift valley. So rift valley is formed due to faulting. Next, 14th is the Great African Rift Valley is a classic example of rift faulting. It is a classic example of which type of faulting? Rift faulting. Remember we discussed Africa, that this part of Africa is what? This part of the Africa we discussed is rifting. So this part is now moving away, because of which rift is being created in case of Africa. And we discussed this part is referred as what? East African Rift Valley. Remember we talked about this particular issue. So East African Rift Valley. This part is something that is okay, rifting in nature. Next, 15 says seismograph is an instrument used to measure earthquake, and it is measuring earthquake vibration. So answer will be C. Next, the most earthquake-prone belt in the world is which belt? It is circum-Pacific belt. Remember, Ring of Fire we talked about circum-Pacific belt. So this belt is something that is okay. What? That is the most volcanic eruption zone also. It is a mostly earthquake-prone zone also. Next, fold mountains are formed due to which type of forces? Again, I don't repeat it. Compressional forces only. Fold mountains are formed due to compressional forces. Next question 18 says the Himalayas are example of which type of mountains? Fold mountains. Yes. Himalayas are example of which type of mountain? Fold mountain. Which of the following is a block mountain? So when we were discussing about the types of mountain, we discussed one of the mountain called Vosges mountain. Vosges mountain is an example of which type of mountain? It is an example of block mountain. Himalayas and Andes are example of fold mountains. So when we have discussed all the mountain ranges, there we have discussed Himalayas are which type of mountain? Fold mountain. Andes are which type of mountain? Fold mountain. Western Ghat. In Western Ghat, what is happening? Faulting are now occurring, but it's not purely a block mountain. The most best example or the most good example of the block mountain is Vosges mountain. Where these mountains are there? Remember we discussed Germany, France, Vosges and Black Forest. So there you will find this particular mountain. So 19th answer will be D. And then lastly, the Andes mountain are located where? These are located in South America. And these are located where? In South America. We discussed Rockies are located over here. And these are located over here. So those were the 20 questions that came in the examination. So these are simpler questions because this was the first test. So simpler questions were given, one-liners were given. But as the test goes up, as you prepare more, then statement-wise questions, assertion, reasoning questions, okay, all those type of questions will be added up. Fine?
So what about the notes?
Notes you have not got?
No, sir.
I am not sure, ma'am is not shared.
No, sir.
You have got?
In the group they are shared.
In the group it is shared. You have got?
We are not in group.
You are not in the group? Just ask ma'am to add, okay?
I'll send it.
Fine. It is already shared. On Friday only I think ma'am would have shared it. So in the last class we were discussing about concept of earthquake. So what was earthquake? What was fine. And we also discussed various reasons behind earthquake, why earthquake is originating. Yeah, volcanic eruptions. Then
Faulting and folding.
yeah, tectonic movement, faulting. Yes. Then we discussed there is a human-induced region also. What are human-induced region? Mining, reservoir-induced seismicity. Yes. What is the difference between what is earthquake swarm? What is earthquake swarm?
Continuous earthquakes without any major.
Yeah, when there is a series of earthquake without any major earthquake, that is referred as an earthquake swarm. We discussed post-shock also, we discussed aftershock concept also. Then we also discussed distribution of earthquake. So we discussed which is the most earthquake prone region. Pacific Ring of Fire. After that, we discussed Himalayas are also there. We discussed the Mediterranean region is also very prone to earthquake. So those are distribution of earthquake we have discussed in the last class. And finally, we discussed consequences of earthquake. What were the consequences of earthquake we have discussed? Avalanches, like landslide, fires, then tsunamis, floods. Yes. So those are the consequences we have discussed with regard to earthquake. Now we'll start with the concept of seismic wave. So as we discussed, energy that is released in earthquake travels in the form of what? Travels in the form of waves. And these waves are divided into two types, body wave and surface wave. Body waves which travels through the body of earth, Body of earth means interior of earth. That is crust, mantle, core region. The one which travels through the body of earth or interior of earth, that is crust, mantle, core. Those are referred as what? Those are referred as body wave. And the second is referred as what? Second is referred as a surface wave. Surface wave travels through the surface. They travels onto the surface. So this difference lies between body wave as well as surface wave. Now body waves are further divided into P waves, that is primary wave, and S wave, that is secondary wave. And surface wave are divided into two types, that is love wave and radial wave. Now these are named after the scientist. Okay, these are named after the scientists who have discovered these waves. Okay, so love was the scientist who has discovered this wave, or Rayleigh was the scientist who has discovered this wave. Both has got Nobel Prize. Okay, for their discovery, they've got the Nobel Prize also. And these are referred as a primary or secondary because this is first to arrive on seismograph, that's why referred as a primary wave. This is second to arrive on a seismograph, and that's why it is referred as a secondary waves. So that's why these are referred as a P wave or S wave. Now before moving to what is this P wave and S wave, just a brief introduction also with regard to waves. So already we have discussed what is a wave. Wave, it is generated due to what? It is generated due to disturbance in a medium. Remember? We discussed why the waves are generated. Waves are generated due to disturbance in a medium. Like we discussed, when you throw stones in a water get disturbed, and that's why waves are generated in the water. So waves are generated due to disturbance in a medium. And what does it? Wave does? It transfers energy from one point to another point. So when wave travels, wave transfers energy. This disturbance which is creating an energy transfers this energy from one point to another point. That is okay, functions of nothing but okay, waves. Clear? Now waves can be classified as a mechanical wave or can be classified also as an electromagnetic wave. So wave can be classified as what? Wave can be classified as a mechanical wave or wave can be classified as an electromagnetic wave. What is mechanical wave? Mechanical wave, remember we talked about Earth's interior, mechanical classification and chemical classification regarding Earth interior. So mechanical classification, what we have discussed?
So the movement and all those.
No, mechanical classification we have discussed is
Lithosphere,
lithosphere, asthenosphere, mesosphere and barysphere. Those are mechanical classification. And what is chemical classification? Crust, mantle, core. These are called as a chemical classification. So we have discussed. So on what basis we have divided mechanical and chemical? On what basis we have divided mechanical and chemical? Forward. Chemical means based on composition. So since crust is made up of silicon, aluminum, we discussed mantle is made up of what? Silicon, magnesium, core is made up of nickel, iron. Their composition is different. That's what we call as a chemical division. And we discussed also the mechanical discussed based on what? Based on in which state they are. So lithosphere is in which state? Lithosphere is in which state? It is a solid block. Lithosphere is which type of block? Solid block. We discussed asthenosphere. Asthenosphere is in which state? It is in plastic state. Asthenosphere is in which state? It is in plastic state. Mesosphere is in which state? We discussed solid part. Outer core is in which state? Liquid state. Inner core is in which state? Solid state. So we discussed the state on which, okay, so that was mechanical classification. So the term, whenever we are using the term mechanical, it deals with certain physical state. It deals with certain physical state. Clear? Whenever we are using the term mechanical, we are talking about certain physical state. So solid, liquid or gaseous state. We are talking about these state. So the waves that requires medium to propagate. The waves that requires medium to propagate are called as which type of wave? Mechanical wave. They either require solid medium, they either require liquid medium, or they require a gaseous medium to propagate. So any wave that requires a medium to propagate, be it solid medium, be it liquid medium, be it gaseous medium, are going to be called as what? Is going to be called as a mechanical waves. Clear? And the waves that do not require any medium and can travel through vacuum. They do not require any medium and can travel through vacuums are referred as what? Are referred as electromagnetic waves. So primarily two differences that you have to keep in mind with regard to waves are mechanical waves and electromagnetic waves. The waves that requires medium to propagate are called as what? Mechanical wave. They require either solid, liquid or gaseous medium, like sound wave. Sound always require a medium to propagate. It requires medium to propagate. Clear? But the light wave, which is an example of electromagnetic wave, do not require any medium. It do not require any medium to propagate. Clear? For example, sunlight. Sunlight travels in the form of electromagnetic radiation. Remember, we talked about gamma rays, X-rays, ultraviolet rays, visible rays, infrared, radio waves. So those are all examples of which type of wave? Those are all examples of electromagnetic waves. Clear? So how these waves are generated? These are generated due to disturbance in electric field or magnetic field. Disturbance in electric field or magnetic field. So they do not require disturbance in a medium, because they are requiring a disturbance in electric and magnetic field. Mechanical wave requires disturbance in a medium. So that's why they need medium to travel. Mechanical waves require a disturbance in a medium. That's why they need medium to travel. While electromagnetic do not require any medium, and that's why they can travel without any medium. They can travel in vacuum because they create disturbance in electric field and a magnetic field. Fine. So this is mechanical wave and this is electromagnetic wave concept. So when we are talking about earthquake wave or seismic wave, when we are talking about earthquake wave or seismic wave, we are talking about which type of wave? We are talking about mechanical wave. When we are talking about earthquake wave or seismic wave, we are talking about which type of wave? We are talking about mechanical wave, because earth crust is, we discussed, crust is made up of solid block, mantle is made up of asthenosphere, which is a plastic state. Then you see convectional current in the mantle. Then you see outer core is in which state? Liquid state. Inner core is in which state? Solid state. So when we are talking about seismic wave, we are talking about which type of wave? We are talking about mechanical wave. We are not talking about these type of wave. Clear? Any doubt regarding this part? Now the third thing. The mechanical wave can be of two types. So mechanical waves are of two types. One is longitudinal wave and second is what? Transverse wave. So mechanical waves are going to be of two types. One is longitudinal wave, another is transverse wave. What is longitudinal wave and what is transverse wave? Now, when the particles of medium, so as we discussed, mechanical wave travels through either solid, liquid or gas. So when particles of a medium, they start vibrating parallel to the direction of propagation of wave, then such type of waves are called as what? Then such type of waves are called as longitudinal waves. So when molecules of a medium start vibrating, start moving parallel to direction of wave, wave is moving in this direction, molecules are also moving in this direction. When they start moving parallel to the direction of wave, then it is called as what? It is called as a longitudinal wave. Like in the earlier classes, we discussed wave travels in the form of either compression and rarefaction, or we discussed waves moves in the form of crest and trough. So which type of wave moves in the form of compression and rarefaction? Longitudinal wave. Which type of wave moves in the form of compression and rarefaction? Longitudinal wave. So remember, we talked about waves moving like this. So molecules are what? Molecules are being compressed, molecules are being expanding, compressed, expanding, compressed, expanding, compressed, expanding. So wave is moving in this direction, molecules are also being compressed and moving in this direction. So if molecules move parallel to the direction of propagation of waves, how the waves is moving, how the energy is being transferred from this point to this point, it is transferred in the form of compression, rarefaction, compression, rarefaction, compression, rarefaction. So waves is moving in this direction, molecules are also moving in this direction. So when molecules move, or molecules of a medium moves parallel to the direction of propagation of wave, such type of waves are referred as what? Such type of waves are referred as longitudinal waves. Fine? Any doubt regarding this one? But so this type of waves, as we discussed, moves in the form of compression. They moves in the form of compression or rarefaction. Then again what? Compression. Again compression, again rarefaction. When the molecules move like this in the direction of propagation of wave, then such type of waves are referred as what? Then such type of waves are referred as longitudinal waves. Fine? Any doubt regarding this one? Like sound wave is an example of what? Like sound wave is an example of longitudinal waves. Sound wave is an example of which type of wave? It is an example of longitudinal wave. Sound wave moves in the form of compression and rarefaction. Now, if the molecules of a medium start moving perpendicular, here it is moving parallel. If they start moving perpendicular to the direction of propagation of wave, then it is going to be called as which type of wave? Transverse wave. So as we discussed, transverse wave travels in the form of which? It travels in the form of crest and trough. So this part is referred as what? Crest, while this part is referred as trough. So in which direction the wave is moving? The wave is moving like this. The wave is moving from this point to this point. Wave is moving. Wave is moving in this direction. Fine. But molecules are moving where? They are moving either up or they are moving either down. So molecules are moving where? Molecules are moving either up or molecules are moving either down. So wave is moving in this direction. Molecules are moving perpendicular to the direction of propagation of wave. So when molecules move perpendicular to the direction of propagation of wave, it is called as a transverse wave. Fine. So in transverse wave, the molecules of a medium moves perpendicular to the direction of propagation of wave. And here in longitudinal wave, molecules of a medium moves parallel to direction of propagation of wave. Fine. So this is basically difference that lies between whom? That lies between longitudinal wave as well as transverse wave. So in longitudinal wave, molecules also move in this direction, waves is also moving in this direction, but here the molecules are moving either up or molecules are moving either down, and waves is moving like this. So molecules are moving like this, waves is moving like this. So they are moving perpendicular, they are making 90-degree angle, they are moving perpendicular to the direction of propagation of wave. So that's why they are called as what? They are called as a transverse wave. So transverse wave, you will see molecules either moving up or molecules either moving down. Clear? Any doubt regarding this particular? So that's why longitudinal waves are also referred as what? They are also referred as compressional waves. Because they move in the form of which? Compression or rarefaction. So that's why they are also referred as a compressional wave. While transverse wave is also referred as a shear wave. Shear wave. Fine, any difference? Now difference is clear. So as we discussed, waves primarily can be classified into two types, which is wave is what? It is a disturbance in a medium, primarily classified into mechanical wave and electromagnetic wave. Mechanical waves are what? Which requires a medium like solid, liquid and gas to move. Electromagnetic wave which do not require any medium, like light is an example of electromagnetic wave, doesn't require any medium. Sound is an example of mechanical wave, requires medium to propagate. Fine. Then we discuss mechanical wave can be further classified into longitudinal wave and transverse wave. Longitudinal wave means here the molecules are moving in parallel to the direction of wave. So either they compress like this, expand, compress, expand, compress, expand. So wave is moving in this direction. Molecules are also nothing but moving like this. But when molecules start vibrating up and down, waves is moving like this. So molecules are vibrating up and down, and waves is moving in this direction. So they move perpendicular to the direction of propagation of wave. Then such type of waves are referred as a transverse wave. Clear? So that's why the transverse wave travels only through solid medium. This type of wave can travel only through which type of medium? Solid medium. This type of wave do not travel in liquid or gaseous medium. They are not able to travel through liquid or gaseous medium. They can only travel through which type of medium? Solid medium. While longitudinal waves can travel through all three medium. They can travel through solid also, they can travel through liquid also, they can travel through gases also. So longitudinal waves can travel through all three medium, that is solid, liquid as well as gases. Solid, liquid as well as gases. While transverse wave travels only through which type of medium? Solid medium. Fine. Why do you think transverse wave only travels through solid medium? We are saying this wave travels through all sides, solid, liquid and gas, while this only travels through solid medium. Why do you think transverse wave can only travel in a solid medium?
So what would be an example of transverse wave?
What would be an example of transverse wave? Like normal wave that is generated in water. Okay, water that you have is like when you throw a stone in water, water moves in what form of what? Waves, crest and trough. Okay, so that is there. So what you see is that is an example of which type of wave. Like transverse wave is not exactly that, but that crest and trough example is what we call as a transverse wave. Yeah. So lot of waves travels in the form of nothing but transverse wave. Lot of waves. Yeah.
So earthquake would be an example of transverse wave.
one type. Like secondary S waves are examples of which type of wave? Transverse wave. Like whereby we are discussing longitudinal and transverses, because P wave is which type of wave? P wave, primary wave is longitudinal wave, while S wave is which type of wave? S wave is an example of transverse wave. So that's why we are discussing this basics. What is longitudinal wave and what is transverse wave? Simple reason is, as we discussed, transverse wave, molecules are vibrating what? Molecules are vibrating here up and down. Clear? So solid has what? Solid has a fixed shape. Let's say if disturbance is created in solid, molecules is going up, what will happen? To maintain its shape, solid, the molecules will be pulled back. Otherwise, okay, what will happen? Solid will not remain in a fixed shape. Like this is a solid. Here what is happening? Molecules is going out, moving up. So what will happen? It will pull back so that it maintain its shape. Clear? But liquid and gas do not have, okay, what? Liquid and gas do not have a fixed shape. What is the difference between solid, liquid and gas? What is the difference between solid and liquid and gas? We discussed solid as what? It has a fixed shape, fixed volume. It has a fixed shape, fixed volume. Liquid has what? Liquid has no fixed shape, but it is going to have a fixed volume. Gas is okay, what? Gas is neither having fixed shape nor having fixed volume. Clear? So this is basically the difference. When you don't have a fixed shape, then what will happen? You will not pull back the molecule. If this molecule is going up, it has to nothing but okay brought back down. Then only what will happen? The shape will be maintained. Otherwise, the shape will not be maintained. If it moves up and remains up, then what will happen? It will deform. Its shape will change. Clear? So if this is a solid part, if it has to maintain like this shape, then if molecule is going up, what will happen? It has to pull it back so that it maintain its shape. That is okay. Clear? Otherwise, it will not be able to maintain its shape. Fine? So that's why, since in transverse wave molecules move up and down, its shape is going to change, and as a result, it only travels through which medium? Solid medium, which has a capability to maintain its shape. The liquid and gas do not have a fixed shape, and that's why transverse wave do not travels in what? Do not travels in case of nothing but okay, solid medium. Clear? Now, which is okay easier to compress and expand out of solid, liquid, and gas? Which is easier to compress and expand?
Liquid and gas.
Liquid and gas is easier to compress and expand. Why do you think?
So because the molecules are loosely packed than solid, and solid molecules are tightly packed together.
So what happens because of that?
So the movement will be easier in
Like waves movement is, we discussed what is wave doing. It is transferring energy from what? One point to another point. What wave is doing? What is the definition for wave we have written? It is transferring energy from one point to another point. That is okay waves doing. How it will transfer energy? When molecules are closer or when molecules are far away?
so closer.
So it will transfer energy when molecules vibrate, collide with another molecules, then what will happen? It will transfer energy. Then we discuss, okay, collide with another molecule, then it will transfer energy. In liquid, molecules are what? They are loosely packed, they are away. So what will happen? It has to get more energy to vibrate and collide with another one. It has to get more energy to vibrate and collide with another one. In gaseous, molecules are much far away. They need lot of energy to collide with nothing but okay, another molecule that is okay there. Clear? So that's why the more propagation of okay transverse wave, the more propagation of longitudinal waves, because longitudinal waves move in the form of what? Compression and expansion. So the more propagation of longitudinal wave will happen where? It happens in solid, followed by liquid, followed by gas. Fine? Any doubt regarding this one? So why the transverse wave only travels in solid? Because solid has a fixed shape, and that's why if molecules are vibrating up and down, it will try to pull back and maintain its shape, while liquid and okay gas do not have a shape, and that's why you don't see transverse wave moving in liquid and gas. While longitudinal wave, its maximum speed is going to be in solid, because here molecules are closely packed. So as soon as okay it gets energy, it will collide with another one, gives energy, transmit energy, that is okay there, which will be less in liquid, further less in gases. So that's why the longitudinal wave has a more speed in solid, followed by liquid, followed by gas. So longitudinal wave have a more speed where? In solid, followed by whom? Followed by liquid and followed by gas. Fine. Any doubt regarding this particular thing? So this is difference you have to keep in mind with regard to longitudinal wave and transverse wave. So what is longitudinal wave? What is a longitudinal wave? When molecules vibrate parallel to the direction of waves in the form of compression and rarefaction. When molecules vibrate parallel to the direction of propagation of waves, then it is called as what? It is called as a longitudinal wave. And in a longitudinal wave, they move in the form of compression and rarefaction. Clear? What is a transverse wave? Their molecules vibrate perpendicular to the direction of propagation of wave, and as a result, here you will see formation of crest and trough. Fine. The longitudinal waves are what? Longitudinal waves are examples are sound wave which travels in the form of compression as well as rarefaction. Fine. As we discussed, transverse wave only travels through which type of medium? Solid medium. Longitudinal waves can travel through which type of medium? They can travel through all three type of medium, but speed will be highest in what? Solid, followed by liquid, and followed by gas. Fine. They can travel through all three medium, but its speed will be highest in solid because molecules are closely packed, then liquid, and then gas. Fine. Any doubt regarding this particular part? So now come to the form of seismic wave. So seismic wave we have divided into P wave and S wave. So as we discussed, P wave is called as a primary wave. Why it is called as a primary wave? Because this is first to arrive on seismograph. We discussed how we study the waves, seismic wave. We record that wave on a seismograph. Remember last class we talked about seismology, study of earthquake is called as a seismology. The graph on which we record the wave is called as a seismograph. So the first wave that is being recorded is referred as a primary wave. Clear? This primary wave is in which form? It is a longitudinal wave. It is a longitudinal wave. While secondary wave is second to arrive on a seismograph, and that's why these are transverse wave in nature. Transverse wave in nature. So primary wave is which type of wave? Longitudinal wave. And secondary wave is which type of wave? Transverse wave. As we discussed, longitudinal wave can travel through all three medium. So it can travel through solid also, liquid also, gas also. It can travel through all three medium. Secondary wave can travel in solid but cannot travel in what? Liquid and gas. Fine. And as we discussed, speed will be greater where? Solid. Speed will be greater in solid, followed by liquid, followed by gas of primary wave. Fine. Fine. So these are referred as what? These are referred as a body wave. These are referred as a body wave. Both of these waves are referred as a body wave. And P wave, as we discussed, longitudinal wave is also referred as which type of wave? Compressional wave. We discussed longitudinal wave is also referred as which type of wave? Compressional wave. While second S wave is referred as which type of wave? Shear wave. So another name for these is compressional wave also and shear wave also. Because it is transverse in nature, we discussed transverse wave, shear wave, longitudinal wave, compressional wave. So P wave is also referred as a compressional wave, S wave is also referred as a shear wave. Fine. Now see this assume this is a earth. This part is what? Crust. This part is referred as a mantle, outer core, as well as inner core. Outer core and inner core. And we discussed body waves are what? Body waves are the wave that travels through the body of water. body of Earth. Body waves are the one which travels through body of Earth or interior of Earth. Interior of Earth. Fine. Let's say now this is the point of origin. This is a point of origin of this is a point of origin of earthquake. This is called as a point of origin of earthquake. Fine. We discussed point of origin of earthquake is referred as focus, or another name for focus is hypocenter. Another name for focus is what? Hypocenter. So this point is referred as a focus or hypocenter. Fine. Now, when this energy is being released from here, earthquake origin point means what? Energy is going to be released. When energy is going to be released, what will happen? We discussed which waves are going to be generated. Body waves are going to be generated. Which waves are going to be generated? Body waves, because energy is being released, and we discussed waves carries energy from one point to another point. So what waves are going to be originated? Body waves are going to be originated. Clear? Now the first wave that is originated, that first wave that arrives on a seismograph is a P wave. Why P wave arrives first on a seismograph? Because P wave travels faster than the S wave. It is 1.7 times faster than S wave. P wave speed is 1.7 times faster than the S wave. That's why P wave are recorded first on seismograph. Whatever wave we are recording, P waves are recorded firstly on seismograph. Why? Because it travels 1.7 times faster than the S wave. Fine. Now suppose P waves are something that are generated. P waves are something that are generated. Now when P wave moves from where to where? P wave moves from where to where? From crust, which is in solid part, to the mantle region. Clear? Now in mantle region we discuss upper mantle is in which state? It is in plastic state. Yes, astrosphere is in which state? Plastic state. Then we discuss again which solid part. You will find waves like this. You will find waves moving like this. Clear? Now you will also find waves moving like this. So you see waves moving like this, that is okay there. Fine. So when here the seismographs are there, seismographs are placed on the surface of Earth. Okay, they are recording the arrival of these waves. Clear? Now suppose now the waves comes like this, and what is happening? We discussed now waves is refracted. The waves is refracted like this, and then moves like this. Waves comes like this, refracted 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 like this. So you are finding this is how the waves are something that are recorded. P waves are something that are being recorded. Here. Now when these are coming over here, so you will see arrival of P waves in this region. You will see arrival of P waves in this region. So till this point to this point, you are seeing P waves are arriving, and till this point to this point, you see P waves are something that are arriving. Here. Now the region where P waves are not arriving, like this region and this region where P waves are not arriving, are called as a P wave shadow zone. This is referred as which type of zone? P wave shadow zone. So the region where P waves are not arriving are called as P wave shadow zones. Here. Now shadow zone means what? That no P waves are something that are arriving. Now why no P waves are something that are arriving over here? Why no P waves are arriving in this region? Why do you think no P waves are arriving in this region? Why it is referred as a shadow zone? Because of rotation of Earth? No. It is because we discussed outer core is in which state? Liquid state. Outer core is in which state? liquid state. So as you know that if the P waves is moving from solid to liquid, what will happen? Outer core is in which state? Liquid state. So when P wave will move from solid to liquid, what will happen? Its speed will change. Just now we discussed, the speed is highest in which medium? Solid, followed by liquid, and followed by nothing but a gas. So when it is moving from solid to liquid, what is happening? Its speed is going to change. Refraction, the wave will be refracted. Wave will be refracted. Speed will change, and that's why you will see arrival of wave in this region. Arrival of wave in this region, but no arrival of wave in this particular region. If Earth was uniform, outer core was not in liquid state, then what will happen? If outer core was not in liquid state, then what would happen?
So magnetic field would not be generated.
Magnetic field not be generated. Any other reason? We discussed when P wave traveling from here to here, what will happen? There will be no refraction because it is traveling through the solid medium only. So when it is traveling through the solid medium, there is no refraction. Waves is not going to refract it. So wave will also arrive in this zone if outer core was in solid state. But since outer core is not in solid state, that's why wave is not arriving in this particular region. Either it is arriving over here or it is arriving in this particular region. So that's why this zone is referred as what? P wave shadow zone. Just quickly make this diagram regarding P wave shadow zone. Make this diagram regarding P wave shadow zone. Whenever light travels from one medium to another medium, what happens? It either bend towards normal or move away from the normal. Fine. So reflection is what? Reflection is like this. Same medium. Okay. What is refraction? When light moves from one medium to another medium, it either bend towards normal or move away from the normal. When it is moving from a rarer to denser medium. Then it will bend towards normal. If it is moving from denser to rarer, it will move away from normal. Clear? So this is how the propagation of light wave happens.
Basically deflection.
Deflection, yes. Okay, you will record deflection. Clear? So this particular point is referred as 103rd degree, and this point is referred as 103rd degree. This point where the wave arrival is there is 142 degree. This point again where wave arrival is there is 142 degree. So we say P wave shadow zone is how much? P wave shadow zone is from 103 to 142 degree. So this is what shadow zone of P wave. This is what we call as a shadow zone of P wave. Fine. So if now go back when we discussed the sources to study the interior of Earth. What are the sources to study interior of Earth? Direct sources and indirect sources. What are the direct sources we have discussed? Volcanic eruption, drilling, mining, those are what? Direct sources. What are indirect sources we have discussed? Earthquake. Remember, earthquake we have discussed, meteors we have discussed, gravity, magnetism. So those are indirect sources. So how gravity is helping us to know about interior of Earth? How earthquake is helping us to know about interior of Earth? When waves are passing, waves are not arriving over here. When waves are not arriving over here, then we are assuming that this state is in which state? Liquid state. If it is not in liquid state, wave would have been arrived over here. Okay, so if it is in liquid state, then that's why you see waves is not arriving over here. Clear? So that's why the wave speed is changing from solid medium to liquid medium. Fine. So this is how the seismic waves are helping us to know about what? Seismic waves are helping us to know about interior of Earth. Fine. Fine. Now Now again consider the same thing. Earthquake is something that is okay, originating over here. Now we are talking about which wave? We are talking about S wave. Now you know that S wave are which type of wave? S wave are which type of wave? Transverse wave. Transverse wave means it will travel only through what?
Solid.
It will travel only through the solid. It will not travel through liquid or gas. So when S wave is originating, you find S wave arriving like this. You find S wave arriving like this. But when the S wave comes over here, it will not enter into what? It will not enter into the core itself. Why it will not enter into the core? Because core is in liquid state. Core is in which state? Liquid state. So that's why S wave will not enters into liquid. When S wave will not enters into this, then S wave will be passing like this. It will pass like this. So S wave will arrive only up to this point. S wave will arrive only this point. This entire region is not where you. This entire region is where you don't find S wave itself. So this is referred as S wave shadow zone. This is referred as S wave shadow zone. Again 103 to 103 degree. You'll see this entire region is referred as S wave shadow zone. Fine. So this is confirming that outer core is in which state? Liquid state. Because we don't see any from the P wave. We are assuming because P wave is not arriving, so we are saying that wave is being refracted. When wave is being refracted, we are saying that this must be what? This must be liquid zone. But which area is liquid zone? Outer core is in liquid zone. Why? Because wave is not arriving like this. Okay, and this is okay referred as a S wave shadow zone. Fine. So this is how the earthquake waves are helping us to know about what? Interior of Earth. The earthquake wave indirect sources to study the interior of Earth. So one type of questions in the mains examination you can get is what? Discuss how seismic waves are helping you to know regarding interior of Earth. One question in the mains examination you can get is discuss how seismic waves are helping you to know about interior of Earth. So you have to make diagram regarding E wave shadow zone. You have to make diagram regarding S wave shadow zone. And since S wave is not passing, shadow zone is bigger. We are assuming outer core is in which state? Liquid state. So that is how you have to talk about. Now, remember we discussed something called density. What is density? What does density indicate? We discussed mass by volume. Density formula is what? Mass by volume. What is density formula? This is the density formula. What does density indicate? What does density indicate? Whether molecules are closely packed or whether molecules are what? Not closely packed. If molecules are not closely packed, it indicates what? Less denser medium. If molecules are closely packed, then it is going to be called as what? Denser medium. Fine? So denser means what? Things are together. Things are closely packed. That is what we call as a denser medium. So if molecules are closely packed, it is going to be called as what? It is going to be called as a denser medium. If they are not closely packed, then it is going to be called as a less denser medium. Fine? Fine. So out of crust, mantle and core. Out of crust, mantle and core. Whose density is maximum? Inner core density is more maximum. So density, as we discussed, increasing from where to where? From crust to core. Density is increasing. So what will happen to the speed of propagation of wave? Speed of propagation of wave increase, because more denser means molecules are more closely packed. More closely packed means what? Waves will quickly transmit energy to another molecule. So speed of propagation will be what? More. So that's how we arrive at what? We arrive at discontinuity. We arrive at what? We arrive at discontinuity. Between crust and mantle, we discuss which type of discontinuity is there. Moho discontinuity. Between mantle and core, which type of discontinuity? Gutenberg discontinuity. How do you say discontinuity is existing? because suddenly you see increase in what? Speed of the wave. Okay, as the things becoming more denser from crust to mantle, things becoming more denser, you will see speed is increasing of wave, and this is how we are knowing that there is a discontinuity increasing, there is a change that is happening between crust and mantle, density is increasing, temperature is changing. That is how we are arriving at these discontinuities. So that's how the earthquake waves helps us to know about what? Help us to know about interior of Earth. Fine? Any doubt regarding this particular thing? So remember, P wave is which type of wave? P wave, longitudinal wave. Longitudinal wave travels through all three medium, but its speed is highest in what? Solid. Its speed is lesser in liquid, and its speed is lesser in gas. When P wave is traveling from what? When P wave is traveling from solid to liquid, its speed changes, waves are refracted, and that's why you don't see P wave arriving in this particular zone, and this is called as what? This is called as a P wave shadow zone. And S wave is which type of wave? Transverse wave. As we discussed, S wave only travels through which medium? Solid medium. So that's why when S wave is coming to the outer core, it is not penetrating outer core, and as a result, no S waves are being recorded over here, and that's why this is referred as S wave shadow zone. Clear? Any doubt regarding the P wave shadow zone and the S wave shadow zone? Okay. Now, we are seeing that P wave is traveling faster, that is it is first recorded on seismograph, then what is coming? S wave or something that are coming. Clear? Now when this P wave, so assume this is crust, mantle and core. Now this is a point of origin of Earth. We discussed this is the shadow zone of S wave. S wave is like this. This is how the shadow zone of nothing but P wave. So this is a P wave shadow zone, and this entire is what? S wave shadow zone. Now this waves will also travel. This wave is traveling in north direction through the body of Earth, and when this wave reaches to the surface, we discussed this point is referred as what? Epicenter. The point of the surface of Earth which first experiences Earth is referred as what? Epicenter. So when body wave reaches to the surface, it becomes what? It becomes a surface wave. It gives rise to the origin of surface wave. So when body wave reaches to the surface, it gives rise to the origin of which type of wave? Surface wave. And surface wave we have divided into two types, which are love wave and rayleigh wave. Love wave and rayleigh wave. Remember, both of these waves are which type of wave? Transverse. Both love wave and rayleigh wave are going to be which type of wave? Transverse wave. Fine. So when body waves reaches to the surface, it gives rise to the surface wave. And surface wave are of two types, love wave and rayleigh wave. Both love wave and rayleigh wave are which type of wave? They are transverse wave only. Clear? Now on the surface, as we discussed, body wave reaches on the surface. When waves are generated, these waves are referred as what? These waves are referred as a surface wave. Now the waves on the surface can propagate in two, either in vertical form or in case of horizontal form. So wave can propagate either in vertical form or wave can propagate either in horizontal form. Fine? Propagation means movement. How the waves are moving, how it is propagating from one point to another point, movement. This can happen either in vertical form or in horizontal form. Clear? So vertical form means what? Let's say this is okay. What? This is okay. The surface. This is the surface. When wave starts to move like this, so it is which form? Vertical form. Crust and trough are being formed. It is okay. Which form? It is vertical form. But if wave starts to move like this, then it is which form? Horizontal form. Clear? So the love wave is which kind of wave? It is a horizontal wave. It is causing the ground to move side by side. Clear? Love wave causes ground to move side by side, while the relief wave is a rolling wave. It causes ground to move up and down. Fine? So these are the two types of wave that are generated. So relief wave causes ground to move up and down. Up and down in rolling form, and it is a vertical one, while love wave causes ground to move side by side in horizontal form. In horizontal form. Fine. So when either the ground is moving like this or it is moving like this means what? The waves are moving like this, horizontally manner. And when it is rolling like this, we are saying waves are moving like vertical manner. So either it can move in a vertical manner or it can move in a horizontal manner, that is clear. Majority of destruction in an earthquake is occurring due to what? Or all destruction on the earthquake is occurring due to what? Is due to the surface wave. It is due to the surface wave. So body wave is not causing a damage because body wave is traveling through what? Interior of Earth. Which wave is okay traveling onto the surface? Surface wave are traveling onto the surface. So majority of destruction, the building collapse, infrastructure loss, okay, the man loss, okay, human life loss, all those happens because of what? Because of surface waves. So surface waves are more dangerous than which type of wave? Body waves. Surface waves are more dangerous than this type of wave? Body wave. Because body wave do not affect you because it travels to the interior of Earth. So as we discussed, out of these waves, the first wave that is recorded on seismograph is what? P wave. Then followed by which wave? S wave. Then followed by wave, Rayleigh wave. Then followed by Love wave. So this is order of wave. This is order of wave recorded on seismograph. This is order of waves recorded on seismograph. Fine. So first wave to arrive on a seismograph is P wave, followed by S wave, followed by Rayleigh wave, and followed by L wave. So the question comes, which of the following wave is having the least speed? Out of all the seismic wave, which is having the least speed? Love wave. Love waves are going to have least speed, that's why it is recorded last. Which is having the maximum speed? P wave. So that's why P wave are recorded first. Clear? And that is the reason, since P wave arrive early, before the Rayleigh wave and Love wave are generated, you see surface waves are, the body waves are created. First, which type of waves are created? Body waves. Yeah? First, which type of waves are created? Body wave. So since body waves are generated and they arrive first, we come to know that earthquake is about to occur, and as a result warning is given. Okay, especially in countries like Japan and etc. You see earthquake warning are given. Okay, around 1 minute 50 seconds before the earthquake is about to occur, warning is being given so that people can come out and take a shelters in those areas where destruction can be minimized. Clear? Why? Okay, so how we get to know that the earthquake is about to occur? Because of P wave. Because it generates early and arrives early on seismograph. Fine. So if question comes, like in means, you may get a question. This type of questions you can get in the case of examination. Discuss the different type of seismic wave and their impact, how the waves help us to know more about interior of Earth. Only one way, reaching to the surface. In the when earthquake occurs, both will be generated. Both will be generated.
So
Whenever
will P wave lead to the generation of other waves, or they are
No.
different only?
no, there are two types of waves that are generated when earthquake occurs. One is called as a P wave and another is called as a S wave. Okay, one longitudinal motion, another which type of motion, transverse motions or something that are generated. Okay, but when P and S wave arrive on the surface, then they generate which type of wave? Relief wave and love wave. And both relief wave and love wave are what? Which type of wave? Transverse wave. They are not longitudinal in nature. Both are in which wave? Both are in transverse wave. So all four waves are going to be generated. Clear? Whenever earthquake occurs, all four waves are going to be generated. That's why we are writing in which order we are going to record this on seismograph. Okay, the first P, then second S, then third is R, the fourth is L. In this order, we are going to record them on a seismograph.
All are different types of earthquake.
All are different type of seismic waves. Okay, earthquake waves.
They generate separately.
They generate separately. Okay, and they arrive one after the other.
So they start from the focus only.
They both P wave and S wave start from the focus, but R and L are generated where? Onto the surface. Okay? When P and S wave reach to the surface, then it gives rise to R wave and L wave. Clear? But from the focus, which two waves are going to be generated? P wave and S wave. Fine. Okay. Can you answer now? होता क्या है? So just now what we discussed is what? That what is the order for arrival of system, the waves on seismograph? The first is what?
P,
P followed by,
S, relay, and lag.
so first is P wave followed by S wave, then followed by R, L. So P wave is first to arrive, then the S wave. Yes, this part is something that is okay, correct statement. This part is something that is correct statement. Second, in P wave, the individual particle vibrate to and fro in the direction of wave propagation. So we discuss either they move in the form of which compression and rarefaction. They move in the form of compression, so either to or fro. So they have a movement of either to or fro. So that is okay, what we call as a compression and rarefaction form. Whereas in S wave, the particle vibrate up and down. So in S wave, we discuss how they are moving. They are moving up and down. They are moving, particles are moving up and down at the right angle to the direction of propagation of waves. So even this is correct, even this is correct. So answer will be what? Both 1 and 2. So like this question has been asked. This is 2023 paper. The UPSC has asked this question in 2023 paper. Fine. So you might get a question also like this in the examination. One only. Only one is correct. Anyone else?
So one is also wrong. One is also wrong.
Why?
So but S wave are deformational, but in solid they will maintain the shape. So they are not deformational.
They are not deformational. Anyone else? Anyone else? Whether they are deformational or not deformational in nature?
But sir, they are also deformational.
How do you say?
They are surface waves, so they cause deformation on the surface.
Which one? S wave or not surface? Surface wave, no? They are not surface wave. Surface wave or L wave? Okay, so they are not different surface. They are body waves. Just think whether they are deformational in nature or not deformational in nature.
So what is the deformation?
Deformation is change in shape. That is called as deformation.
So they are not deformational.
They are not deformational. Now let's say if I try to stretch something, okay, what will happen?
Tear apart.
Tear apart. Let's say rubber I am trying to stretch.
Expand and contract.
it will expand and contract. Okay, so what will happen is, okay, let assume if any material, if I try to stretch and contract, when compressed, this wave is moving in the form of what? Crest and trough. So it is trying to expand the material, contract, expand and contract. After a certain point of time, material will lose what? Its elasticity. Okay, so when rubber loses its elasticity, what will happen? It becomes, okay, bigger in nature. Like that, when rocks also constantly, if, okay, they are subjected to up and down motion, what will happen? Over a period of time, they will lose their shapes. Okay, and that's why S waves are referred as which type of wave? Also referred as a deformational wave. Clear? Any doubt regarding this particular thing? So S waves are referred as a deformational wave. They distort the shape because molecules are moving up and down. After a certain point of time, they will lose what? Elasticity, and they will what? They will lose their shapes. Clear? So this is the reason why you see landslide occurs. No, we discussed landslide. Why landslide occurs? Why landslide occurs? We discussed the rocks are what? Rocks are like this, and when rocks loses its shape, what will happen? They starts to fall down under the influence of what? Gravity. That is okay there. Clear? So that is the reason why you see landslides occur. So yes, this part is very much correct. Second is wrong. S wave shadow zones are smaller than P wave. This is what, okay, we are writing. But as per our, okay, the diagram which have more one, S wave 103 to 103 degree entire region. So S wave shadow zones are bigger than the P wave. Fine. So S wave do not arrive from there to there, from here to here, while the P wave only do not arrive from here to here and here to here. So P wave shadow zones are smaller, S wave shadow zones are bigger in nature. So like this also you can make question in the case of examination. Clear?
Sir, what about P waves? Aren't they deformation?
P waves can also be deformation. They can also be deformation. They compresses, they change the shape, they can also be deformation. Any doubt regarding this one? So these are what? These are the important points that you have to keep in mind with regard to seismic wave. Now, the next part is what? Next part is when earthquake occurs, we discussed it can occur of different magnitude. Energy can be released, different magnitude energy can be released, and this magnitude is measured through which scale? Richter scale. Yes, okay, this magnitude is measured with which scale? Richter scale. So last class we discussed two scales, Richter scale and Mercalli scale. Mercalli scale measures what? Intensity, while Richter scale measures what? The magnitude. Clear? So generally, what you see is yeah. So generally, when you see magnitude of earthquake 1 to 1.9, up to okay what? Up to 0 to 1. Up to 0 to 1, this is going to be called as what? This is okay going to be called as a micro. Up to 0 to 1, okay, this type of okay, the earthquake is going to be called as micro, and after that it is going to be called as a minor earthquake. After that it is going to be called as a minor earthquake. So from okay the up to 4, okay, you will see nothing but okay, what? Up to 4 you will see which type of earthquake? Minor earthquake. Then after 4 what will happen? 4 to 4.9 we call it as a high earthquake. After that 5 to 5.9 which type of earthquake? Moderate earthquake. Then after that 6 to 6.9 it is going to be called as a strong earthquake. After that it is called as a major earthquake. It is called as a major earthquake, very major earthquake. After 6.9 it can cause a lot of destructions. Fine. So these are okay what? These are nothing but okay different classification of earthquake based on what? Based on magnitude, how much energy is being released. But as we discussed, depending upon the location where the earthquake is occurring, you will find what?
Different inside.
You will find different destruction level, intensity will be different. Even a moderate earthquake can cause what? Bigger damage. A strong earthquake may not cause a bigger damage depending upon the location. Fine. Now, there is a body called GSI. This is called as the Geological Survey of India. Geological Survey of India. This was created by the Britishers in 1851. So this was created. This body was created during Britishers period in 1851, and currently this body is working under Ministry of Mines. So under which ministry this body is working? Under the Ministry of Mines. So Geological Survey of India classifies India into different seismic zones, depending upon intensity. Are you right? Oh, chances of occurrence. So, depending upon chances of occurrence, or we can also write vulnerability of a place. India is being classified into different earthquake zones. Clear? So, who prepares this particular seismic zone with regard to India?
GSI.
It is prepared by GSI, Geological Survey of India. This body was created during Britishers period in 1851, and as we discussed, it works currently in which ministry? It works currently in the Ministry of Mines. Okay, in prelims you may get a question regarding all these bodies: Geological Survey of India, Forest Survey of India. You have Botanical Survey of India, Geological Survey of India. So all these bodies you are going to get questions in the case of examination. So remember that Geological Survey of India prepares a seismic zone map of India. It prepares a seismic zone map of India, and which region of India is more vulnerable and which region of India is less vulnerable to earthquake. This is what being classified. By the Geological Survey of India. So as we discussed, which part of India is more vulnerable to the earthquake?
So
Himalayan region. This region, as we discussed, plate tectonics. So the Indian plates is colliding with the Eurasian plates. That's why you'll see this is called as a zone 5. This is referred as a zone 5. Highest probability, highest occurrence of earthquake you'll find in this region. That's why it is referred as a zone 5. Surrounding region, even surrounding region in this region, surrounding region here, it is classified into zone 4. Zone 4 means they are second most vulnerable. Clear? So surrounding region around Himalayan region, Himalayan plate tectonic, as well as nothing but Gujarat and this region, you are going to call it as a zone 4 region. Zone 4 region, they are the second most vulnerable region. Then you will find Then you will find further region which is called as a zone 3, and then you will find this Deccan Plateau region which is referred as a zone 2. So zone 2 is Zone 2 is a least seismic zone, where the chances is very less. Chances of earthquake is very less. Least seismic zone, that is called as a zone 2, and zone 5 is what? Highest seismic zone. Zone 5 is highest seismic zone, while zone 2 is a least seismic zone. This classification is done by whom? This classification is done by the Geological Survey of India. Fine. In mains you may get a question regarding explain the vulnerability of India with regard to what? With regard to seismic zone. So as per GSI, 59% of India's area, 59% of India's area are vulnerable to earthquake. 59% of India's area is vulnerable to earthquake. Fine. So depending upon the vulnerability, also we need to go for what? We need to go for development also in these regions. Why? Why? Because if you are creating a structure which cannot withstand, okay, even a slight earthquake, then what will happen?
Disruption.
As soon as, okay, the earthquake occur in this region, the structure will get destroyed. So more loss of life, more other things are happening. So why we are classifying this zone? Based on the vulnerability, we have to plan our development also. So where we have to, okay, create which type of houses, which type of infrastructure, where we have to create which type of, okay, development, where we have to create, okay, shelters in case of earthquake and etc. Where they can, okay, where they can, if let's say lot of loss of life is happening, buildings is not there or the homes lost, so where they can survive. Okay, so we have to, okay, we have to plan for all those particular things, and that's why Geological Survey of India is classifying India into different zones, so that will decide different type of developmental pattern that we have to follow in different regions. Clear? Any doubt regarding this one? Now if you look at the map, so you can see this particular map, and what you are finding, we discussed zone 5 is going to be what? Highest seismic zone region. Orange color is what? Zone 5. So orange color is your zone 5. So this entire northeast region, you see this region, you see this region, these are, okay, classified as what? These are classified as a highest seismic zone. Then you see zone 4. Zone 4 is surrounding, adjoining region of zone 5. This is called as nothing but, okay, what? This is called as nothing but, okay, zone 4 region. Then the yellow color represented by zone 3. This is, okay, zone 3 region where other chances of earthquake is there, and the most safest zone is your zone 2. This is, okay, zone 2, that is, okay, there, which is a least seismic zone, which is a most stable zone, least seismic zone, that is, okay, there. Clear? So as per GSI, we discussed 59% of India's is under what? 59% of India's is in the seismic zone. And this part, Andaman and Nicobar, again heavily, okay, what? Heavily nothing but, okay, seismic zone. Zone 5. High vulnerability also in Andaman and Nicobar. You'll see less vulnerability where? In Lakshadweep. Lakshadweep comes under zone 3. Lakshadweep comes under zone 3. Clear? So this type of, okay, what? Seismic map. Whenever this question is coming in the mains examination, try to make this seismic map. In case of examination, you will get a question regarding what? You will get a question regarding classify India's area as per what? As per seismic zone vulnerability. Clear? Also, in paper 3, you have a concept of what? You have a topic called disaster management. In GS paper 3, mains examination, you have a topic called disaster management. So if disaster occur, how you are going to manage this disaster, that is mentioned under GS paper 3. So there you also get a question regarding what? There you are going to get a question regarding earthquake, disaster, and what are the precautions, what are the preparedness, what are the problems, okay, that you are going to face when you encounter an earthquake, and how you will deal with such particular situation. Clear? So this is what you have to keep in mind with regard to seismic zone of India. And who prepares this map?
Geological Survey.
Geological Survey of India prepares this map. Fine. So this is all about seismic zone of India. Okay. Have a break and then we'll further continue. So next we are moving towards tsunami. Another impact of earthquake, another impact that earthquake has is tsunamis. So tsunamis are generated where? Tsunamis are generated on the oceans. They are generated in the oceans. They are a wave. Tsunamis are called as a long waves that are generated in oceans. Generated in oceans due to sudden release of energy because of earthquake. So sudden, these are the long waves that are generated in the ocean due to the sudden release of energy because of earthquake. Fine. So this is referred as what? This is referred as the tsunami waves. So whenever an earthquake occurs over here, you will see energy being released. This energy will generate a wave. So whenever earthquake occurs over here, this will release energy. This energy will cause a generation of waves, and these waves are referred as a tsunami waves. So tsunami waves are differs from the other wave, which is called as a normal waves. So normally the waves are also generated in the oceans because of what? Because of the friction. Because of friction between wind and water. So normally these waves are also generated because of friction between wind and water. Let's say this is water, and the wind is blowing. When wind is blowing, what will happen? It will try to take away water with it. So that's why there is a friction that is generated, and this friction causes waves to generate in the oceans. This type of waves are referred as a normal wave. Okay, so normal waves are generated because of friction between wind and water. While tsunami waves are long waves that are generated due to release of energy due to earthquake. So normal wave has a frequency of around 5 to 20 seconds. They are generated in between 5 to 20 seconds. They have a frequency of generation. While they generally have a long generation. It could be 10 minutes to 2 hours. Long generations. So that difference you have to keep in mind with regard to tsunami waves as well as normal waves. Now tsunami waves are also referred as a harbor waves. These are also referred as a harbor waves. The term tsunami is coming from where? Coming from Japan. The term tsunami is coming from Japan because these waves are more frequent in Japan. Earthquakes are more generated near Japan because of ring of fire. So that's why the term tsunami is coming, and these are generated near the harbor. That's why it is called, also referred as a harbor wave. What is harbor means? The term harbor means the place where ships are docked. The place where ships are docked. These are referred as a harbor. Clear? The place where ships are docked, ships are kept. Those are referred as what? Harbor. And where unloading and loading of goods and other things that you do is called as a ports. So ports and harbors. Clear? Dock means they are placed, they are kept. Fine. So this, since these waves generate near the coast, harbor, that's why they are referred as a harbor waves also. Now, the tsunami waves so let's say this is oceans. Now the tsunami waves, when generated in the oceans, you'll find lot of waters over here. But as you come near to the coast, so this is a land part. So this is the ocean part, this is nothing but okay land part. So as you are coming to the land, what will happen to the depth of the water?
Decrease.
Depth of the water is decreasing. When here waves are traveling over here, you will see depth is more. Clear? So when depth will be more, water is more, then what will happen? What is going to happen? Energy is going to be distributed. Energy is going to be distributed. But as what is happening, as it is coming near to the coast, what will happen? The depth of the water is decreasing. When depth of the water is decreasing, what will happen? Here, as we discussed, depth of the water is more. That's why waves can travel with a faster speed. Because more water is there, more energy can be moved in all the direction. So that's why the waves here travel with a faster speed. But as we are moving towards the coast, what is happening? What is happening? Waves are moving with slow speed. Slow speed. Why? Because depth of the water is decreasing. Depth of the water is decreasing. Okay? Depth of the water is decreasing. So that's why wave speed will become slow. And that's why amplitude of the wave becomes larger. You'll see this is okay what? This is called as a amplitude. This is called as the amplitude of wave. Fine. So when the waves are okay coming near to what? Near to the coast, the depth of the water is decreasing. Because of the depth of the water, waves are becoming slow, and that's why you'll see waves height is going to increase. Waves height is going to increase as we are moving towards what? We are moving towards coast. Fine. And when the height will increase, what will happen? What will happen? You will see more amount of water is going to come from the coast near to what? Near to the land. Clear? So as the height of the wave is increasing, more amount of water from the coast will come onto the land, and this will cause the flood or destruction onto the land. This will cause flood or destruction onto the land. Fine. So this is what happens in case of tsunami waves. When tsunami waves are generated in the oceans, what you see, waves travel with the fastest speed. Why wave travel with the fastest speed? Because of more amount of water. There is more water and waves can move faster, that is okay there. But as the waves are moving towards the coast, depth of the water is decreasing. When depth of the water is decreasing, what will happen? The wave speed will slow down. Wave speed will slow down. And you know that energy, you have studied about formula, okay, that energy is what? Neither created nor destroyed. Okay. What will happen? Conservation of energy. Energy is always conserved. So you have studied about that. So what is happening when waves is slowing down? What will happen to the energy? Energy has to be conserved. Okay, energy has to be conserved, and as a result, what will happen? You'll see height of the wave is going to increase. Wave's height is going to increase to conserve the energy, and that's this height, this extra height of the wave that is okay coming will bring more amount of water towards what? Will bring more amount of water towards the land. This will cause flood or destruction. This will cause flood or destruction. Fine. So this effect is referred as a shearing effect. This effect is referred as a shearing effect. The waves okay what? Waves height is going to increase as it approaches towards the coast, and this effect is referred as what? This effect is referred as a shearing effect. When waves are here, their height is okay less. When waves are moving towards the coast, their height is increasing, and this effect is referred as what? This effect is referred as a shearing effect. As we discussed, okay, here what is happening? The speed is faster. Why? Because depth of the water is more. As you move here, speed will decrease. Why it will decrease? Because depth of the water is what? Less. But energy of the wave has to be conserved. Energy is conservation of energy. Energy has to be conserved. So energy has to be conserved. So if speed is decreasing, what will happen? Height has to increase. Height has to increase in order to conserve what? In order to conserve the energy. So that's why the increase in height leads to what? This effect is called as what? This effect is called as a shearing effect.
sir, the tsunami grows larger and larger near the
near
coast.
the coast. That's why it causes more damage. As it approaches towards coast, it becomes more larger and larger and causes more damage. If you are in the if tsunami is occurring and you are in the middle of oceans, then what will happen? You will feel lesser effect because of more amount of water. Waves will be distributed. But when you are coming to the coast, less amount of water is there. Waves will not be quickly distributed. Energy will not be quickly distributed, and that's why you see larger and larger waves are going to be there. Fine. So this is referred as what? This is referred as a tsunami waves. So you might get a question regarding discuss, okay, the causes behind origin of tsunamis, what are the destruction that tsunami can cause, which are the areas that are more prone to tsunamis. So wherever, okay, you see like ring of fire, Pacific ring of fire, we discussed, oceans are there. There, if okay, the earthquake are going to generate it, if earthquake is going to be generated, what will happen? We'll see generation of tsunami. That's why Japan, New Zealand, all these regions are more prone to tsunamis. In India, the tsunami has occurred where?
Tamil Nadu.
In Tamil Nadu region. Yes, okay. In 2004, 2005, you see generation of tsunamis over here. As we discussed, this region, Andaman and Nicobar, remember? We discussed it is highly seismic prone region. Highly seismic prone region, zone 5. Just now we discussed zone 5. It lies in zone 5. So if earthquake occurs over here, you will see generation of tsunamis, and the tsunamis can cause something what? Can cause destruction in Tamil Nadu region. Yeah. Now, there's something called mangroves also. Though you will study that in environment. Mangroves are the plants which survives in what? Which survives in salty conditions. Which survives in which type of condition? Salty condition. Normally plant grows in which type of water? Fresh water. Plant doesn't require salt water. Plant grows in a fresh water. But mangroves are the special type of plants which can survive in what? Which can survive in a salt water. So these type of mangroves are generally found where?
Near the coastal areas.
Near the coastal areas, because sea water is which type? Salty in nature. So that's why you will see this type of mangrove plants are found in the salty region. But nowadays, what is happening is we are removing these plants. We are removing this plant, mangroves being removed. Why it is being removed? Because we are expanding. Urbanization is happening. That's why these are being removed. So in 2004, India realized the problem that when tsunami struck and okay, you saw Tamil Nadu regions okay, were heavily impacted by the tsunami. Then we realized the importance of mangrove plants. Suppose that government is trying to conserve more amount of mangrove plants over there. We are trying to plant more amount of mangroves so that when tsunamis comes and other comes, these act as a buffer. These plants act as a buffer when tsunamis and other things come. They slows down the speed of the tsunami waves and etc. And that's why minimize the destruction that can cause on the land areas. So that's why mangroves is one of the way to protect people from the tsunami waves. Clear? So these are important points you have to keep in mind with regard to tsunamis. Fine. So this is all about your earthquake. We discuss earthquake, terms related to earthquake, causes of earthquake, distribution of earthquake, where earthquake is occurring, magnitude of earthquake, how it has been classified, strong, moderate and other thing. Then we discuss seismic waves, P waves and S waves, and L wave and R wave. Then we discuss what? Then we discussed okay, the seismic classification of India, how it is being classified from zone 5 to zone 2. Then lastly we discuss which type of waves, tsunami waves, which is generated because of earthquake. Okay? So this is all about earthquake. Yes.
So was this in 2004 when the government decided they should plant more mangroves? And now, sir, is it the same?
Yeah, mangrove is okay. What mangrove concentration is increased over a period of time.
Okay.
We are trying to conserve more amount of mangroves now, and its concentration is increasing.
Because in Mumbai, sir, they are cutting down mangrove trees.
Yeah, they are cutting down mangrove trees. Overall, as we have a record as per State of Forest Report, SFR. So every 2 years, this report is being released, a State of Forest Report, which talks about how much forest we have, how much tropical, like ever forest you have, deciduous forest you have, mangrove forest you have. So as per data regarding SFR, we have an increase in mangrove cover. That is what okay you have to keep in mind. Yes, at isolated places you will see cutting down of mangroves being done, but overall as a whole in India we have an increase in mangrove cover.
Okay. So sir, there is a report which also maintains the forest amount, how much.
Yeah, we have a national forest policy, as per which our target is that India's 33% area should be under the forest. This is National Forest Policy 1988. This target was fixed in 1988. So as per National Forest Policy 1988, 33% of India's area should be under what? Should be under the forest. And currently, if you look at as per SFR report, it is somewhere around 25.16. This much area of India is under what? Under the forest cover and tree cover. So this includes both cover, forest cover and tree cover. Fine. So this is the latest SFR data that you have to keep in mind. So as per SFR, yes, increase in mangrove cover has happened, but it's still isolated places. We'll see cutting down of mangrove. But currently, government is more focusing on conservation of mangroves. Okay, because we have realized the importance of mangrove post tsunamis. Fine. So next part that we are going to now take up is what? Volcanism. So remember, we discussed heterogenic, the slow or sudden. Slow is called as what? Diastrophism. Sudden is called as what? Catastrophism. So catastrophism, we discussed, we divided into two parts, earthquake and volcanic eruption. So now we are done with the slow part also. Sudden, we are done with the earthquake. Now we are coming to which one? Volcanic eruption. So what is basically a volcanism? What is basically a volcanism? Volcanism is when molten magma, along with that ash, dust, other pyroclastic material comes out from interior of earth, it is referred as what? It is referred as a volcanism. So what is a volcanism? When molten magma along with the ash, along with the dust, along with the pyroclastic material, this comes out from interior of earth, then it is referred as what? Then it is referred as volcanism. Fine. Now, this volcanism, what is this pyroclastic material? What is pyroclastic material? The material that comes out from the vent, and flows. These materials are referred as what? These materials are referred as a pyroclastic material. So material that comes out and flows are referred as what? Pyroclastic material. Fine. What type of ashes means? Ashes means the dust particle, other particles that comes out. And what is a gas? Along with that, okay, you'll also see gases coming out. What is the gases coming out? What are the gases coming out? Like sulfur dioxide. The gases that comes out from the volcanic eruption is what? Sulfur dioxide. So that also you will see. So along with molten magma, ash, dust, pyroclastic material as well as gases, these are going to come out from volcanic eruption. Fine.
Which type of materials come from?
Pyroclastic materials are material that flows out of the vent. Vent is okay. This is okay. This is from where magma is coming out. So along with when magma comes out, we discuss it flows. No? So the material that flows from the vent and spread is referred as which type of material? Pyroclastic material.
Composition is asking, right? Sir, composition, sir.
Composition,
Composition.
as we discussed, what comes out? You can have high content of silica, you can have low content of silica. So that is okay there. So depending upon what material, iron can come out, other thing can come out. So whatever material that are flowing out is referred as what? Is referred as a pyroclastic material. Fine? So this volcanic eruption can be classified into different types. These can be classified into different types. So these are the different types of what? Types of volcanic eruption. Types of eruption, it can be classified as a fissure type, or it can be classified as what? Vent type. Or in case of frequency of eruption, active volcanoes, dormant volcanoes and extinct volcanoes. In terms of magma content, it can be classified into andesitic, acid volcano, basic basaltic or shield volcanoes. Andesitic acid is also referred as a composite volcanoes. Okay? Like it is referred as a shield volcano, it is also referred as a composite volcanoes. It is also referred as a composite volcanoes. Fine. So first of all, what is the reason why volcanic eruption occurs? What is the reason why do you think volcanic eruption occurs?
Too much of heat.
Too much of heat.
Conventional currents.
Yeah, it is because of convectional current that are generated in the mantle region. Okay, so the main causes of volcanic eruption is what? The main causes of volcanic eruption is a convectional current that are generated in mantle region. This is convectional current generated in mantle region. We discuss why this convectional current are generated.
Pressure, sir, due to rotation of
Due to rotation of Earth, anyone else? Why this convectional current are generated?
some because of magma, sir.
Because of magma. Magma is formed due to this particular convectional current. Why this convectional current are generated?
Because of the heat that is present.
How this heat comes?
Increase pressure.
Increase in pressure. Any other?
So due to the internal plates movement.
Due to internal plates movement. The reason is, we discussed radioactivity. What happens in the mantle region? We discuss radioactivity, and because of this radioactivity, what is happening? Heat is generated. This heat is responsible for what? Generation of what? Convectional current. So we discuss this is okay what? This is a mantle region. This is okay your crust region. Here the convectional current are generated because of what? Because of heat. And this convectional current can move like this. Can move like this. And with this, when this convectional current are strong enough, they can come out on the surface in the form of what? In the form of volcanic eruption. So one of the major reason for the volcanic eruption is convectional current that are generated in mantle, and this convectional current are generated due to what? Due to nothing but okay, radioactivity or earth's heat. We also call it as a earth's heat. Remember two things we have discussed: sun's heat and earth's heat. So we discussed all weather phenomena is happening due to sun's heat. All internal processes is happening due to what? Earth's heat. And earth's heat is okay because of the convectional current that are generated in mantle region. Fine. Now, where the volcanic eruption will occur? Where the volcanic eruption will occur? Two major regions where you see volcanic eruptions are going to occur. One is divergent boundary, and another you are going to see is convergent boundary. So wherever the plates are diverging or wherever the plates are converging, there you're going to see what? There you're going to see the volcanic eruption to occur. So generally volcanic eruptions are going to occur either at a divergent boundary or convergent boundary, and we call it as what? We call it as a plate margin. We call it as a plate margin. So generally volcanic eruptions are going to occur at a plate margin. Fine. So what is plate? So we discussed lithosphere is divided into what? Various blocks. It is not a continuous block, rather broken down into many parts which are referred as a plate. So plate can come together. If they are coming together, they are going to be called as what? Convergent. If the plates are something that are moving away, then it is going to be called as what? Divergent. Okay, then it is going to be called as a divergent. So this particular edges is called as what? This particular edges is called as a plate margins. Edges of margins are means what? Margins means what? Edges. So majorly the majorly the volcanic eruptions are going to occur where? At the plate margin. But there is a special kind of volcanic eruption that can occur within the interior of plates also. Let's say this is a plate, within the plate, not at the margin. So sometimes you see volcanic eruption can also occur at the middle of the plates. Majority where it occurs? Majority of the volcanic eruption occurs at the plate margin, but sometimes you will also see volcanic eruption occurring in the middle of the plates, and such type of volcanic eruptions are referred as a hotspot volcanism. Such type of volcanic eruptions are referred as a hotspot volcanism. Fine. So there are two types of volcanic eruption. One is occurring at the plate margin, that is convergent or divergent plate margin, and secondly that can occur within the plate or interior plate. Such type of things are called as what? Such type of things are called as a hotspot volcanism. Fine.
So this is batholith, right, sir? This will be batholith.
No, not batholith. We'll discuss. Okay, batholith. Just now again we'll take up volcanic landform. Different landforms are going to form. So there we'll discuss batholith again.
So
Yeah.
hot springs and hot spot both are same.
Both are different. Okay. Wait for a hot spring. We'll come to the hot spring also. So what you have to keep in mind is whenever the plate, just remember this, where the volcanic eruption occurs, most of the volcanic eruption occurs at the plate margin, that is at either the convergent boundary or at a divergent boundary. But sometimes the volcanic eruption may occur at the interior of the plate. When it occurs at the interior of the plate, it is called as what? It is called as a hotspot volcanism. For example, you will see we discussed why Himalayas are formed. Himalayas are formed currently due to collision between whom? Indian plate and Eurasian plate. Indian plate and Eurasian plate. This is collision that is happening. Before this collision has not happened, where was the Indian plate? Because collision will happen when they come together. So it is coming from somewhere else, no? Then only it is colliding with whom? Colliding with the Eurasian plate. So before Indian plate was not colliding with the Eurasian plate, from where it was coming?
Australia.
It is part of Africa. It was part of Africa. Indian plate has broken down from where? from the African plate. It has broken down from African plate. So from here, it has moved towards what? It has moved towards Eurasian plate. So from here, it has moved towards something but okay, Eurasian plate, that is okay there. Clear? So when we come to Indian geography, we will discuss. There is okay what? There is an island currently over here, which is called as a Reunion Island. This island lies where? In the Indian Ocean region. This is Indian Ocean region. So this island lies where? In the Reunion Island lies in which region? Indian Ocean region. So currently here lies a Reunion Island, but when Indian plate was passing earlier through this point, when Indian plate was passing through this particular point, Indian plate suffers which type of volcanism? Hotspot volcanism, and this hotspot volcanism led to formation of what? Deccan Plateau. So Indian Deccan Plateau is formed due to what? Indian Deccan Plateau is formed due to hotspot volcanism. Clear? And as we discussed, if volcanism occur within the interior of plate, then it is going to be called as what? Then it is going to be called as a hotspot volcanism. Clear? So Indian Deccan Plateau is not a result of what? Not as a result of plate margin volcanic eruption. It is a result of formation of which type of eruption? Hotspot volcanism. Clear? So normally, as we discussed, most of volcanic eruption happens at the plate margin, whether at convergent plate margin or at divergent plate margin. But sometimes volcanic eruption can also happen at the interior of plate. In this type, when it happens at the interior of plate, it is called as what? Hotspot volcanism. Fine. Where it will happen in the interior, we'll take up later, because hotspot volcanism will take up later. First we'll discuss okay the plate margin concept. Fine. Now, why volcanic eruption occurs at the plate margin? Suppose this is one plate, this is okay another plate. This is one plate and this is okay another plate. As we discussed, plate are moving over here. Plate are moving over asthenosphere. So we discussed this is a plate are lithosphere. They are moving over what? They are moving over which layer? Asthenosphere. And in this region, what is happening? You'll see convectional current are generated. In mantle region, which type of things are generated? Convectional current are generated. Fine. Any doubt? Now, what will happen if plate will move apart? If plate will move apart, what will happen?
Fault is created.
Fault is created. Any other thing? If plate is moving apart, fault is created when?
Forces of tension.
Forces of tension. But here the plates are not joined together. No, when plates are joined, then what will happen? Fracture will be created. Clear? If plates are joined, then what will happen? Fracture will be created, tension will be created. Here the plates, there are two different plates. Clear? So they are moving away. There is no tension that is occurring in the plate. The plates are like this and they are moving away. Clear? Already fractures are there. They are moving away. What will happen?
So space will be created.
Space will be created. Yes, space will be created. What will happen because of the space creation? What will happen?
The pressure that is
Yeah.
present under the ground will come out.
Yeah, pressure will be released, because if I am putting certain things, let's say if I am putting this particular thing over here, what will happen? This layer will feel the pressure. But if I am removing this, what will happen? Pressure is now released. Now pressure is released, then what will happen to magma? What is happening to the magma? Okay, it will come out. Okay, because earlier why it was not able to come out? Because pressure was there. Okay, magma was not strong to break this pressure and able to come out. But when this plates are something that are moving away, then what will happen? Pressure is being released. Now the plates are moved like this. One plate had moved over here, another plate had moved over here. This is okay what? Asthenosphere. This is where you see convectional current. Now pressure is released, so this convectional current will come out and you will see which type of eruption? Volcanic eruption. You will see which type of eruption? You will see volcanic eruption. So one of the areas where you see lot of volcanic eruption is what? Is divergent boundary. Why divergent boundary? Because when plates are diverging, what is happening? Pressure is being released. Pressure is being released means what? Convectional current can easily now come out, and this can cause what? This can cause volcanic eruption. Fine?
So lifts are created due to tension, sir.
Huh?
Lift valley is created due to tension.
Rift valley is created due to the tension. Yes.
It's also like tension, sir.
For rift valley to create, what will happen? Let's say this is a plate. This plate is now broken down into what?
Two places.
Two plates. Okay. or we can say this rocks can also be broken down into what? Two rocks, okay, that is okay here, fine. But what will happen if they are already separated? Will it be tension? There will not be tension. Tension will be there when they are joined together, and what will happen? You are trying to pull them apart. But if they are already not joined, what will happen? Tension will not be there. They are moving because they are moving away because of what? Because of convectional current. This convectional current is trying to move this plate over here, and this convectional current is trying to move this plate over here. Clear? So they are moving because away from each other because of what? Because of convectional current. And when they will move away, what will happen? Pressure will be released. When pressure will be released, what will happen? Eruption will be there. Fine. So this is a reason why you see most of volcanic eruption is occurring at the divergent boundary. But this type of volcanic eruption is not going to be what? This type of volcanic eruption is not going to be explosive type. Explosion will not happen. Why explosion will not happen? Why explosion will not happen?
So because the plates will be
Because already space is being created. Already space is being created, it can easily come out. When when pressure is there, it is not allowing it to come out, then what will happen? It has to explode and come out. Clear? So that's why this type of eruption is not going to be explosive type. This normal eruptions is going to be there. Explosive eruptions are not going to be there because already space is being created. Volcanic eruption, magma can easily come out. If magma is not being allowed to come out, then what will happen? Magma has nothing but burst it and come out. Then explosion will happen. Clear? So that's why the thing that happens at a divergent boundary is not going to be what? Is not going to be of explosive eruption. This is not going to be of explosive eruption. Fine. What will happen at the convergent type? What will happen at the convergent? Let's say this is a plate. We discussed plates are now converging. What will happen?
So they compress.
They will compress. Any other thing?
And magma has to force itself out.
Yeah, magma has to force itself out.
Explosion will happen.
Fine. Any other thing?
So formation of volcanic mountains will be.
Volcanic mountains. The first thing, as we discussed, when two plates are coming together, they can be either lighter plate and they can be either denser plate. We discussed plate can be either lighter plate or plate can be either denser plate. If both are lighter, then what will happen? Remember Himalayas creation? We discussed Indian plate is lighter, Eurasian plate is lighter. That's why what is happening? Upthrusting is happening. Okay, if one plate is denser and another plate is less denser, what will happen? Subduction will happen. Okay, so wherever at the conversion is happening, wherever which type of boundary you will see volcanic eruption at convergent boundary, and which type of convergent boundary where two plates are of different density. If they are of same density, then what will happen? If both are lighter in nature, then what will happen? Upthrusting will happen. Then volcanic eruption will not happen. Like we discussed, Himalayas is devoid of what? Any volcanic eruptions. Clear? So at convergent boundary where the plates are coming together, what should happen? Subduction need to happen. So another region where you see the volcanic eruption will occur is at convergent boundary. At convergent boundary where subduction is something that is happening. Clear? Now because of these plates coming together, what will happen? Because of this plate coming together, what will happen? You will find the lighter plate will remain as it is, while denser plate will start to go down. Subduction will happen. So denser plate will start to go down. Clear? Now what will happen here? Convectional currents are already there. Astrosphere there. Denser plate is now going down. When denser plate goes down, what will happen? It will expose to higher temperature. As you go down to the earth, go down in the interior of earth, what will happen? Temperature will increase. When temperature will increase, what will happen? This part will melt. This part will melt, and as a result, now it has to come out in the form of what? In the form of volcanic eruption. So it has to break this. It has to break this plate and come out. And as a result, this type of explosion, this type of volcanic eruption will be which type? Explosive type. This type of volcanic eruption is going to be which type? Explosive type. Clear? So as the denser plate is going down, what will happen? As the denser plate is going down, what will happen? There will plate melting will happen. Why plate melting will happen? Increase in temperature. When increase in temperature, it will melt. Magma, okay, will form. This magma will come out by breaking this, okay, lighter plate, and this type of eruption will be which type of eruption? Explosive type eruption. So generally, all the eruption that is okay happening at the convergent boundary is going to be which type? Explosive type. Generally, all the eruption that is okay happening at the divergent boundary is okay which type? It's non-explosive type. That is okay. That's why we have this classification. So that's why we have this classification. Type of eruption we have divided into fissure type and vent type. Fissure means what? Fissure means a break. Fissure means a break. Clear? So when there is a break is there. When there is a break, when there is a rupture, what will happen? Space is already being created. When space is already being created, magma can easily come out. So that's why fissure type is what? Fissure type is a non-explosive type of volcanic eruption. And what is a vent? As we discussed, magma has to force itself. Magma has to break the rock, force itself to come out. So that's why vent type is okay. Which type of volcanic eruption? Explosive type of volcanic eruption. So that's why this type of volcanic eruption is going to be of explosive type. So depending upon the type of eruption, you can have either fissure type or you can have either vent type. Vent type means magma is going to come out through a narrow path. This is a narrow path through which magma is coming out. This is a narrow vent. Clear? Now magma is trying to come out because magma has to break. Magma has to break. So magma is coming from the narrow path and then breaking to come out in the form of what? Volcanic eruption. So such type of eruptions are going to be of explosive nature. Fissure type, magma can easily come out because already rupture is there. Already space is being created. So this type of eruption is going to be what? Non-explosive type. Yeah, any doubt regarding this one? So that's why based on types of eruption, whether explosion is happening, non-explosion is happening, we can classify volcanic eruption into fissure type or vent type. Fine. Now here we have written that this type of volcanic eruption, which is okay divergent boundary, where you are seeing this type of volcanic eruption. Generally, this type of volcanic eruption you are seeing in which ocean? Atlantic oceans. You are seeing this type of eruption where? In Atlantic oceans. So where you see the divergent type of volcanic eruption, you are seeing divergent type of volcanic eruption in the Atlantic Ocean region. Clear? So here you will find where is the Atlantic Ocean? You will find like this. So this is Europe, this is Africa, this is North America, and this is South America. Now here, this is okay. This ocean is referred as what? This ocean is referred as the Atlantic Ocean. Now you will see this at this ocean. You will see the oceans are diverging. Okay, here you will see diversion is something that is okay happening, and because of which volcanic eruptions are going to be there. Because of which what is happening? Volcanic eruptions are going to be there, and this volcanic eruption leads to formation of what we call as the ridges. This volcanic eruption is leading to the formation of what? Ridges. Fine. So we discussed what is ridges. What is ridges? Below the water, parallel mountain chain. Yes. Okay. So when you will see this is what? This is your Atlantic oceans. And when eruption is happening over here, you will see parallel mountain ranges are going to be formed. These parallel mountain ranges are going to be called as what? These are called as the ridges. So that's why one of the major volcanic eruptions that you are finding is in Atlantic Ocean, and in Atlantic Ocean you will see formation of ridges. You will find formation of ridges in the Atlantic Oceans. This ridges formation is due to which type of volcanic eruption? Divergent type of volcanic eruption. Now, suppose this was okay the situation first. Now what had happened? The plate had diverged, volcanic eruption has happened. Now because of volcanic eruption, what will be formed here? What will be formed over here? When this lava cools and solidifies, what will be formed? New rocks, new crust are going to be formed. New rocks or new crust are going to be formed. That's why divergent boundary is referred as which type of boundary? That's why divergent boundary is referred as which type of boundary? Constructive boundary. Here construction is happening. New crust are being created. That's why this type of boundary is referred as what? Constructive boundary. Clear? And in convergent, what is happening? We discussed denser plate is what? Denser plate is going down. When denser plate is going down, what will happen? This plate will melt because of high heat. When this plate will melt, what will happen? Here destruction is happening. Plate is being destroyed. Plate is being melted. So that's why the convergent boundary is referred as which type of boundary? Destructive boundary. So convergent boundary is referred as destructive boundary. Divergent boundary is referred as a constructive boundary because new crusts are being created. Here crust is being destroyed. Here crust is being destroyed because of melting. Crust is being destroyed. So that's why you will see more ridges creation. Ridges are being created. Here. That's why Atlantic oceans are called as what? Atlantic oceans, we say that it is expanding. Over a period of time it becomes, currently which is the largest ocean? Which is the largest ocean we have? Pacific Ocean. Pacific Ocean is the largest one. Over a period of time, let's say millions and millions of years, Atlantic Ocean will become what? Bigger than Pacific Ocean. Because at Pacific Ocean you see convergence is happening. It is converging. While the Atlantic Ocean is what? Diverging. So Atlantic Ocean will become bigger over a period of time and Pacific Ocean will become what? Will become smaller because of convergence. So why in Pacific Ocean what is happening? So we discussed this is okay what? This is your North America. This part is what? Southern America. This part is your Australia. This part is your Russia, Japan, Indonesia. Fine. So you are finding this particular region. So here which plates is there? North American plate. Here which plate is there? This plate is Eurasian plate, Australian plate. Now this is your Pacific Ocean. This is your Pacific Ocean. So here Pacific plate is now being colliding with whom? Pacific plate is now colliding with which plate? South American plate. It is colliding with which plate? It is also colliding with which plate? It is also colliding with which plate? Australian plate. So now Pacific plate is now being converged. All these plates are trying to converge. Which is a denser one? Which is a lighter one? Pacific plates are denser. Why? Why Pacific?
Plates they are.
Mafic rocks. Yes, okay. Continental crust are made up of which type of rock? Felsic. Continental crust are made up of felsic. Oceanic crust are made up of mafic. And we discussed oceanic crust are more denser than what? Continental crust. So which is okay? Which plate is more denser? Oceanic plate is more denser. Pacific plate is more denser. While these are what? Continental plate lighter. So what will happen to lighter plate? What will happen to lighter plate? It will remain up. And what will happen to denser plate?
Go down.
Yes, okay, subduction will happen. So that is what happening over here. So you see denser plate is going down, subduction is happening, lighter plate is remain okay as it is. And when it goes down, what will happen? Pacific plate is melting. Pacific plate is melting, and because of Pacific plate melting, what will happen? Volcanic eruptions are going to happen. And that's this which type of volcanic eruption now going to happen? Which type of volcanic eruption now going to happen? Explosive type. Explosive type. Why? Because convergent boundary. We discussed convergent boundary. Which type of explosion will happen? Explosive type. It has to break the continental crust to come out in the form of what? In the form of volcanic eruption. Here already plates are diverged, so you don't have to break it. It will come out as it is. Fine. But here it has to break it and come out. So which type of explosion will happen? Which type of explosion? Explosive things will happen over here. Fine. So that's why this region is referred as what? This entire region is referred as ring of fire. This entire region is referred as a ring of fire or circum-Pacific belt. So why ring of fire? Because what is coming out? Hot lava is coming out. So hot lava is coming out, that's why it is called as what? Ring of fire. and this entire region is also referred as a circum-Pacific belt. Now we have discussed which mountain lies over here. Which mountain lies over here? Rockies. Which mountain lies over here? Andes. Andes lies over here. Rockies lies over here. Now go back to mountain ranges. Which type of mountain we have written regarding Andes? Whether fold mountain, block mountain. Which type of mountain we have written regarding Andes? Andes is a fold mountain. Whether we have written it is also a volcanic mountain. We have written Andes is also which type of mountain? Volcanic mountain. Why volcanism? Because of subduction. Because this Pacific plate is subducting. When Pacific plate will subduct, what will happen? Volcanic eruption will happen. So that's why Himalayas do not have this volcanic eruption. But Andes is a fold mountain. Folding is happening because two plates are colliding, converging. So folding will happen. But here also subduction is happening, and that's why volcanic eruption will happen. In Himalayas, what is happening? Indian plate and Eurasian plates are what? They are nothing but coming up, but no subduction, rather upthrusting is happening, and because of this, no volcanic eruption. So Himalayas is only a fold mountain, Andes is fold mountain also, and volcanic mountain also. Fine. So wherever you will see volcanic eruption, at the plate margin, and which type of plate margin? Divergent and convergent. You will see divergent and convergent. Fine. Any doubt regarding this part? So that's why remember this classification. So on the basis of types of eruption, we can classify volcanism in what? Into fissure type and pentile.
Excuse me, sorry for the interruption. People used to say there is the Indian plate and Eurasian plate are they are coming towards here. Hence the Himalayan Indian plate, Himalaya it is growing. Is it true?
Yeah, is it true, sir? This collision is still going on. Okay, like when Indian plate and Eurasian plates are like this, Eurasian plate is now moving up, Indian plate is now moving up. So it's
going downwards.
Yeah, and because Indian plates and Eurasian plates has collided, there was a sea over here. This sea is referred as a Tethys Sea. So this sea is referred as a Tethys Sea, and here lot of sediments at the bottom of sea, lot of sediments were present. So now when these things are coming together, what will happen to sediments? These sediments will now be folded up. Okay, so because of these sediments only fold up, we see the creation of Himalayas. So since collision is still going on, sedimentation is still rising. So that's why Himalayas are still rising. So this we'll discuss in Indian geography part. We'll discuss Tethys Sea, how it is formed, how it is created. This all we'll discuss in Indian geography part. Fine. So right now just remember that in India volcanism is what? Volcanism is not happening in a Himalayan region. Why it is not happening? Because convergent plate boundary is there, but both plates are lighter in nature. Indian plates and Eurasian plate both are lighter in nature, and that's why no volcanic eruption in the Himalayas. In the case of what? In the case of Andes, one plate is lighter and another plate is denser, and that's why you see what? Volcanic eruption is there. Fine?
Sir, African Rift Valley is constructed due to diverging or?
African Rift Valley is being constructed due to faulting. Faulting is happening and divergent is happening. Fault is happening. First of all, we discuss strikes with fault and dips with fault. So what is happening if one of the things will go down? What will happen? Normal fault, and this will create block mountain, and this lower part will create what? Rift Valley. And after that, now they are what? They are now diverging. So that's why we are saying that over a period of time, this this part will come out and this part will come out. Fine. So here development of Rift Valley has started. That's why you'll find many lakes right now over here. Fine. So this is all about types of eruption, and here we discussed magma content. Based on magma content, we have andesitic or we have basic basaltic or shale volcanoes. So second, based on magma content, we are classifying this into two types. Fine. Now, what material that is coming out? What material that is coming out? That will decide whether it is going to form andesitic acid or composite volcanoes, or it is going to form basaltic, basic, or the shield volcanoes. So last class we discussed, remember we discussed the igneous rock can be divided into what? Acidic and basic. The igneous rocks is formed into what? Cooling and solidification of magma only. So magma that is coming out can be either in acidic form, can either be in basic form, that is okay there. So when magma have a high content of silica, then what will happen? Acidic. And magma will have low content of silica, then what will happen? Basic. Low content of silica, then basic. Fine. So high content of silica, we discussed what will happen?
Less crystal formation.
Yes. You will see the formation of volcanic eruption like this. So lava will what? Lava will not flow to a great distance. Lava will not flow to a great distance. Why? Because magma is highly viscous in nature. Remember viscosity we discussed? Viscosity is what? Resistance to flow. So since it contains high amount of silica, the magma is what? Magma is highly viscous in nature, and when magma is highly viscous in nature, magma will not spread. When magma will not spread, what will happen? Volcanic mountains are going to form. Yes, it will form volcanic mountains. Right? And when magma is what? When magma is going to spread, flow to a greater distance, then it is going to be called as what? It is called as a basaltic, basic, and this will lead to formation of what we call as a volcanic plateaus. This will lead to formation of volcanic plateaus. Here magma is fluid in nature, not viscous in nature. Rather we say magma is fluid in nature. Fine. So that's why we discussed Deccan Plateau. Deccan Plateau will contain which type of rocks? Basaltic rock. So Deccan Plateau is made up of basaltic rock. Fine. Now again here, which type of eruption generally andesitic acid or composite have which type of eruption? They generally have explosive type of eruption, while basic basaltic have which type of eruption? They have generally fissure type eruption or non-explosive. Here the magma comes out in a non-explosive manner. Here the magma comes out in what? Magma comes out in an explosive manner. Okay, so in andesitic acid composite, you see magma comes out in what? Explosive manner. Here magma comes out in explosive manner. Here magma do not comes out in an explosive manner. Fine. Why this happens?
So because there is space for in basaltic, there is space for the magma to cool down. In fissure type also there is space for the magma to cool down.
It is because, as we discussed, let's say this is a vent through which magma is coming out. This magma contains high percentage of what? Silica. Means magma contains high percentage of silica. As a result, we discussed this magma will not flow to a great distance. This magma starts to cool and solidifies where? Near to the vent. Okay, so near to the vent only it is cooling and solidifying. Yeah? Now, when it is cooling and solidifying over here, what will happen? It will block. Yeah? It will block the magma to come out. So now magma has to what? Now magma has to break this cooling and solidification part to come out. Okay, that is okay there. So that's why what will happen? Explosion will happen. Clear? Because cooling and solidification is happening near to the vent. When cooling and solidification will happen, this part will get blocked. This vent will get blocked. As a result, what will happen? The new magma has to what? Explode and come out. Fine. So that's why this type of eruption is what? This type of eruption is explosive type. But in case of in case of the fluid, magma flows through a great distance. When magma flows, cools and solidifies, this part is not getting blocked. When this part is not getting blocked, then what will happen? New magma can easily come out. So that's why this has a which type of eruption? Fissure type or non-explosive type of eruption. Well, this has a which type of eruption? Explosive type of eruption. So generally composite volcanoes Composite volcanoes have an explosive type of eruption. The shield volcanoes do not have an explosive type of eruption.
So acid composite volcanoes are composite in nature.
Composite in nature. Composite means what? As a whole.
Explosive.
Composite means as a whole. The term composite means what? Literal term of composite means when you are seeing something as a whole, that is called as a composite thing. Clear? So composite means something as a whole. So here magma cools and solidifies and near the vent, and as a result you are seeing as a whole. In shield, what is happening? You are seeing magma is spreading. Magma is okay, cooling and solidifying in layers. That's why it is called as what? Shield.
Sir, I mean convergent.
Which one?
Acidic one will be.
Acidic is convergent. Yeah, it can happen in convergent. Acidic can also happen in case of in case of the convergent margin. It can also happen in the case of hotspot volcanism. It can also happen because interior of plate, no, hotspot volcanism where it happens, interior of plate. So there also you can see nothing but the explosion can happen. Right? Clear? Now the third type of volcanic difference we have written is what? On the basis of frequency of eruption. So on the basis of frequency of eruption. So on the basis of frequency of eruption, we have classified them into what? Active, dormant and extinct volcano. So if volcano is regularly erupting, then it is going to be called as which type of volcano? Active volcano. So if frequency of eruption is regular, it is regularly erupting, then it is going to be called as which type of volcano? Active volcano. If dormant means what? Dormant means the volcanic eruption is not regular. It is not regular. Chances are there that eruption may happen. Earlier happened, chances of eruption as that in future also it may happen, but currently regularly it is not erupting. That type of volcanoes are called as what? That type of volcanoes are called as a dormant. Dormant means okay, lying low. Okay, something that is lying low. So chances are that in future it may erupt, but currently it is not erupting, and that's why it is called as which type of volcanoes? Dormant volcanoes. If no chances of eruption, it has lost all the magma and there is no chances of further eruption, then such type of volcanic eruptions are referred as what? Such type of volcanic eruptions are referred as the extinct volcanoes. Clear? Any doubt regarding this part? So active volcanoes are those volcanoes where there is regular eruption of magma. Dormant volcanoes are those volcanoes which once has erupted, but okay, in future chances are there that it may erupt, but currently it is not erupting, then that's why it is called as what? Dormant volcanoes. And extinct volcanoes which once erupted but no chances in future that it will erupt, that's why it is called as a extinct volcanoes. For example, one of the example of extinct volcanoes is Mount Kenya. Mount Kenya, it lies in Kenya, so this is an example of what? Extinct volcanoes. Okay, dormant volcanoes you will find Barren Island, that you can find. Barren Island is an example of the dormant volcanoes. There is also Mount Kilimanjaro. Barren Island. Barren Island lies in Andaman and Nicobar. It is a part of Andaman and Nicobar. So Barren Island is which type of? It is a dormant one. Mount Kilimanjaro is which type of dormant one? Yeah. There is active. You can write Anak Krakatau. This is an active one. Lies in Indonesia. We discussed Mount Etna. Yes, that also you can write. Mount is also there. Hawaiian Island. We discussed earlier. Mount Kia. Mount Etna. Stromboli is there. Vesuvius is there. These lies in Italy. These mountains lies in Italy. Mount Stromboli, Mount Vesuvius. In fact, Mount Stromboli is also referred as what? It is also referred as a lighthouse of Meridian. Lighthouse of Mediterranean region. It is referred as a lighthouse of Mediterranean region, Mount Stromboli. So where you will see Mount Italy, you will find Africa over here, you will find Europe over here, and here you will see extension in Mediterranean Sea. This sea is which sea? Mediterranean Sea. You will see extension in Mediterranean Sea. This part is Italy. So here you will see Stromboli Vesuvius is there. So why eruption is happening over here? Why eruption is happening over here? We discuss African plate is colliding with what? African plate is colliding with Mediterranean region. Okay. So there is okay, but denser one, there is a lighter one, which lead to nothing but which lead to the volcanic eruption. So another region which is okay, very high in volcanic eruption is this region. So Atlantic Ocean, one of the reason we have discussed, which is rich in volcanic eruption. Another we have discussed is what? Circum-Pacific belt, which is very rich in volcanic eruption. Another region, Mediterranean region, very rich in volcanic eruptions. Fine. So that's why I'll just. Now, this you are finding, you can see this is written as what? Mid-Atlantic ridge. So we just now discussed if volcanic eruption will happen, in the Atlantic Ocean, what is being formed? Ridges are being formed, and these ridges are referred as what? These ridges are referred as a mid-Atlantic ridge. Okay, these ridges are referred as a mid-Atlantic ridge. So you see this is happening, and here you see formation of what we call as a ridges. This ridges is referred as a mid-Atlantic ridge. Fine. This is happening in the Atlantic Ocean. Here you see a lot of island, like you can see this is written as a Cape Verde. Cape Verde. Now here you will find another island which is called as a Canary Island. Canary Island. Here you will find something called Iceland. All these are which type of island? Volcanic island. All these are which type of island? Volcanic island. This is okay forming due to what? Volcanic eruption inside which region? In the Atlantic Ocean region. Here, so you'll see formation of ridges. You'll see formation of these islands like Cape Verde Island, Canary Island, Iceland Island. All these are being formed due to what? Being formed due to volcanic eruption. Clear? And this region that we talked about is what? This region is we talked about is Italy, and this region is a Mediterranean Sea region. So here you'll see a lot of eruption happening. That is Stromboli, Vesuvius. And that's this region is referred as what? Lighthouse. As we discussed, Stromboli is referred as a lighthouse of Mediterranean region. Clear? So another eruption that you are finding in this particular region. Fine? Any doubt? Now another important thing that you see, so you can see this region is written as a ring of fire region. So this region is written as a ring of fire region. You can see this region. This is referred as what? This is referred as Aleutian Island. This island is which type of island? Aleutian Island. This all island that you are finding is which type of island? Aleutian Island. So this is one of the important island that is formed due to volcanic eruption. Whole Japanese island is which type of island? Volcanic island. Philippines. that is okay there. You can see Anak Krakatau, just now we discussed, okay, this is one of the, okay, active volcano, you will find where in Indonesia. So this is, okay, Indonesia. You can see New Zealand Tonga Belt, important volcanic eruption. You will see all this Andes region, important volcanic eruptions, okay. So you see this important volcanic eruption regions, these are, okay, being formed. And as we discussed, when plates will go down, what will happen? Subduction. So this is, okay, what, this is one plate, another plate is going down, subduction is happening. So this region, the lower region is referred as what? This lower region is referred as the trenches. What is being formed in the ocean? Trenches are, and that's why you can see Aleutian Trench, Ural Trench, Japan Trench, Mariana Trench. You can see all these trenches are referred. So what is trenches? Trenches are nothing but, okay, when one plate is subducting below another plate, this region is, okay, what, this region is referred as nothing but, okay, trenches region. Okay, so this region between the two plates, which is, okay, one plate is subducting below the another plate, is referred as what? Trenches. That's why you find all these trenches, okay, Ural Trench, Japan Trench, Aleutian Trench, all these trenches names are there over there. Fine.
Trench and arc are both same, sir?
No, trench and arc are different, okay. Arc is like your Andaman and Nicobar is which type? It is arc. Andaman and Nicobar Island is like this, okay. So that is, okay, Andaman and Nicobar Island. Fine. So arc is basically what? Let's say this is a circle. When you are cutting the circle, whatever point that you are getting is an arc, okay. So that is called as a volcanic arc. When let's say Japan, you are seeing how it is being created. So Japan, how you are seeing being created? Japan, you are seeing like this. So you will see Japan being created like this. This is, okay, various island of Japan. One island, another island, another island. You will see, so Japan, when many islands are created like this, it is going to be called as what? It is going to be called as an arc. It is going to be called as an arc. Fine. So this is, okay, what? This is important part that you have to keep in mind with regard to what? With regard to volcanic eruption. So which are the areas or plate margins which are having frequent volcanic eruption? Are your circum-Pacific belt, Mediterranean region, Atlantic region. These are the regions which is experiencing frequent volcanic eruption. Fine. So remember, volcanic eruption can be classified based on three types. What are the three types we have discussed?
Types of eruption.
Types of eruption: explosive type or non-explosive. So explosives are called as a vent type. Non-explosive is called as a fissure type. Then secondly, based on frequency of eruption, it could be active, dormant, extinct, and third is what? Correct. Answer question 3.
All four.
All 4. Yes. Okay. So answer will be all 4. So what is coming out from volcanic eruption? We discussed pyroclastic material, ash and dust are coming. Then we discussed gases are coming. Which type of gases? Just now we discussed sulfur dioxide is coming. So sulfur, okay, compound is coming. Nitrogen oxide is coming. So which is called as what? Nitrogen oxide. So those type of gases are something that are coming, and that's why it is referred as what? All 4 are going to be answered for this one. So this is how the question has been asked regarding what volcanic eruptions have been there. Clear? This is the reason why you see tomorrow we'll take up this concept. So you'll find this nitrogenous compound is also coming in the form of volcanic eruption. So this nitrogenous compound means nitrogen oxide, sulfurous compound means sulfur dioxide. So when water reacts with sulfur, it is going to form what? Sulfuric acid, H2SO4. When water is going to react with NO2, it is going to form what? Nitric acid, that is HNO3. So HNO3 formation will happen, H2SO4 formation will happen. So this formation leads to what? This formation leads to what? This formation leads to acid rain. Okay, so sometimes you see rain becoming what? Acidic in nature. Why rain becoming acidic in nature? Because these are acids. These are acids. Sulfuric acid, nitric acid. So when rainwater react with what? When rainwater react with sulfur dioxide, when rainwater react with nitrogen oxide, it is going to form what? It is going to form sulfuric acid or nitric acid, and this will cause what? This will cause acid rain to occur. Clear? And this acid rain is not good. Why it is not good?
So it is harmful because of acid content.
Yeah, because soil becomes acidic, and if soil becomes acidic, we discuss plant will what? Can plant grow in acidic medium? No. We discuss plant requires fresh water. Okay, so they require fresh water. They can't grow in acidic medium. So that's why you don't see what? You don't see the environment. You don't see environment in a good condition with the acid rain. Also, limestone, CaCO3. Remember, calcium carbonate. We discuss limestone formation. Limestone will corrode with acid. When limestone react with acid, what will happen? It get corrode. So that's why you will see CaCO3 will cause what? CaCO3 will react with sulfuric acid. It will react with nitric acid, and that's why there was a famous case in environment. You will study about a famous case called MC Mehta case. MC Mehta was a person who filed this petition in the court, and regarding what? Regarding the pollution, regarding removing the factories away from Taj Mahal areas and other areas, because marble is getting what? Marble is getting corroded with with acid rain and other rain. It is damaging the structures and etc. Taj Mahal areas. So that's why relocation of industries were done from the Agra area to Mathura areas. Refineries were moved out from there. So this was a famous case, MC Mehta case, related to the environment. Fine. So from the refineries also, you see coming out of what? Sulfur dioxide, nitrogen oxide. So that also contribute towards what? Acid rain. Clear? So remember this particular concept of acid rain. Volcanic eruption can also cause what? Volcanic eruption can also cause a acid rain. It can also cause a acid rain because of release of sulfur compound and nitrogen compound. Fine. So this is all about volcanic eruption that is happening at the plate margin, and we have also discussed wherever distribution of volcanic eruptions are there. Clear? Rest regarding what is hotspot volcanism and what are the positive and negative of the volcanic eruption. Like one negative we have discussed. What is the negative thing? Acid rain. But what is the positive thing? New crusts are being formed, new materials are coming out, which is helping in mining and other things. So there are certain positive of volcanic eruption, certain negative of volcanic eruption. So we'll take up that in the tomorrow's class. Any doubt regarding this particular thing? Thank you.
Thank you, sir.